Hi, this is Shapu Nia, and in this lesson, I'm gonna talk about what a PLC is, how it works, and some of its practical uses. A programmable logic controller, or PLC for short, is simply a special computer that can be programmed for use in automation of electromechanical processes such as control of machinery on factory assembly lines, oil refineries, or water or wastewater treatment plants. But most likely, you encounter PLC-based controllers every day without even realizing it, in simple applications such as traffic lights, elevators, or even your home security system. In general, every PLC has three main components: inputs, outputs, and the CPU. The CPU, or Central Processing Unit, is the most important element as it's able to accept commands from the inputs, process them using the program designed on a computer, then send the information to the outputs to be executed. The CPU acts as a hub for all the activity that occurs in a PLC. Inputs are used to translate signals for the CPU to process. When you're installing a PLC in an industrial process, the process inputs must be connected to the PLC inputs. For example, one process input can be a push-button switch. When the button is pressed, it sends an electrical signal to the PLC inputs. This signal can be a current or voltage signal. This electrical signal is then passed through the PLC inputs and turned into logical data. Because the CPU is a computer system and cannot process raw electrical signals, the inputs must translate the electrical signal before sending it into the CPU. Once the CPU has processed the data is sent through outputs. Outputs are used to translate the CPU's logical data back into an electrical signal for use in the industrial process. This is because industrial processes use electrical signals to operate, instead of the logical data that a CPU outputs by default. For example, if we have an electric motor connected to a PLC output using a contactor, the contactor must be triggered electrically so that when it's activated and deactivated, it will turn the motor on and off. So, in order to activate the contactor, an electrical signal must be applied, and the PLC output uses the CPU's logical data to send electrical signals to the contactor. Like the PLC input signals, the output signal can be either a current or voltage signal. This diagram now shows a complete PLC system. A push button sends an electrical signal to the inputs, which then translates the electrical signal into logical data. The CPU then processes the data and delivers it into the PLC outputs, and in return, the outputs translate the data back into an electrical signal, And finally, the signal is applied into the industrial process. So, here the CPU operates as the main unit of the PLC, and the inputs and outputs connect the CPU to the rest of the industrial process.